So we're here at the Parallax Expo, and we're looking at the magnetic mini submersible done by acelab.com. And I guess it's a M field system, M for magnet?
Yes.
Okay, so magnet field system or magnetic field system. So how did you come up with this idea?
I was used to teach electromagnetics in high school, so I was looking for an interesting way
to demonstrate it. Sure. That's great.
The principles. Came up with this.
So is it just like a field of magnets that you have underneath there?
No, it's the structure
all
around.
Okay, yeah.
Generates the magnetic fields. It's a three-dimensional magnetic field generator.
Very nice.
So is it 12 electromagnets there?
It's just 6.
Just 6?
1 per side.
Okay, gotcha. So it's a bit like how a cathode ray tube works, but in 3D.
Exactly.
Yeah.
The other one is just XY, and this one has the other.
And what's required on the actual unit there? I noticed there's a few wires on it. What are those?
The wires are just counterbalance to make it almost neutrally buoyant.
Okay.
But it has a magnet in there. So the only thing that's required is a magnet and that it's almost neutrally buoyant.
What was the worst part about making this project?
Maybe
most difficult?
I think coming up with the right amount of wire to make the coils.
Sure.
And the label. I actually built a machine to do the coils, so I wouldn't have to
do it by hand. That's great. And so, do you have an aquarium tank at home?
No, this is
that's it. That's great.
I do this just in my spare time, so I have a lot of time.
Sorry. So you're still teaching now? Yeah.
No, I'm actually working.
Okay.
That's very cool.
So my PLC is actually because this is by
What happens?
the cheapest chip these days is ground chip.
This is just to wire the coil.
Ground chip, the box with the one standard
Oh, that's nice.
You don't have to screw it every time.
I'm building a robotic camera chip in our studio that this gets mounted on, and the fulcrum point is up in the ceiling, so the chip comes down and it can lift the camera up and swing it left, right, and it's got a pan tilt on it. And I just designed the H-bridge for the big motor up on top, and every single one of the channels, it's all discrete, so there's all the big ones. I wish I could have got away with using one of those chips, it would have been nice, but the current I need is crazy.
What's the current you're using?
Oh gosh, they're TIP 20s, so fairly, an amp or more, something up in there. I'm using it at about 1.2 amps, I think is the max. I'm doing PWM control. John S. at AZ on Twitter helped me design it. He was a manufacturing engineer at Motorola until he retired. So he's got a lot of cool things built into it. So I can do pulse width modulation off of a pin on the propeller, and then another pin controls left or right. So I can just left or right and then pulse it at whatever speed I want it to. And I designed the software so that it ramps up and ramps down. Yeah, it's the same problems that you're doing,
It's just
multiple dimensions that you're dealing with. Completely different application.
Joe Grand.
Yeah, Grand Idea Studios.
Yep. Hi, Joe.
Hi.
And there's a lot of people around, so we're gonna
give us
try
a
to
little
sneak this
spiel.
in.
What's going on here?
Okay. So I have a bunch of stuff set up, but probably the coolest thing, or one of the coolest things, I guess, is this laser rangefinder to Game Boy printer hack that I did a little while ago. This is the first time that I've actually brought it out in public to show people. And what it is one of the laser rangefinders that I designed for Parallax, which is has a little CMOS camera on one side, a 640 by 480 CMOS camera, and a laser diode on the other side, and basically takes a frame, picture frame, or an image capture with the laser off, and then an image captures the laser on, figures out where in the frame the laser spot is, and then uses trigonometry to calculate the distance from the rangefinder to the target object. So sort of a cool little device. But I wanted to do something a little more fun with it, just to show the kind of hackable side of things. So what I did is just used the camera side to take a frame grab and then dump it over an SPI bus to the Game Boy printer, old school Nintendo Game Boy printer. And so I'm just showing that off, just for fun and trying to take pictures of people as they walk by.
It's a little stalkerish there.
It is, yeah. But here, I'll try to take a picture of Whisker controlling the camera. Oh, my battery just died. New 9-volt.
Engineering.
Ready? Let's switch.
This is Joe Grant changing a 9-volt battery.
How many engineers does it take?
That's gonna go viral.
Change a battery. Yeah, you can cut this part out. Okay, ready? Let's see. So, cheese. Say cheese.
Cheese.
Okay. So it took the frame, grabs the frame really fast, but then it has to send it serially over a pretty slow interface to the Game Boy printer, and it starts to print out.
Whisker looks like a camera.
I am a camera. Didn't you guys know that?
That must be the, yeah. I can't even see what that is. The resolution is 160 pixels across, 2 bits per pixel.
2 bits per
2
pixel.
bits per pixel color. So it's not very impressive resolution. But you can sort of see some things. I took a picture. Here's me giving a thumbs up. Here's an Elmo toy. There's my Grand Idea Studio sticker. So
It does decently.
it's decent.
With
It's
good
cool.
with good contrast.
Given that this was made in 1989 or something, and designed for video games to print things out on, it's kind of fun.
Yeah.
But anyways, this is a fun
Actually, you
little
probably
thing.
would have made bank if you had done this back
In
then.
1989,
Yeah.
would have made tons of money.
Yeah. Oh well, 2020 hindsight. So we are here with woohoo, Jack Goldschmidt.
Yes.
Yay! And you can find him on Twitter, and that's how actually we know him. So he's a real
And
person.
if you build it, he will modify it.
Yes, correct. So,
That's what it is.
so it looks like here we have the Propeller project, and or is that how it's said?
That's what it is.
Okay.
Yes, Propel.
So what is it?
Propel was named after one of the engineers that originally designed the 6502 processor, Chuck Peddle. And the project is a 6502-based software-defined computer. Basically, it's a real 6502 processor that's controlled by a propeller processor. And the propeller also controls the RAM that's on board the propeller project board. And basically the propeller is in charge of presenting all the hardware that would normally be in a 6502 based computer to the 6502 processor.
Now, for those who don't know, the 6502 was a processor that was in a lot of vintage computers going back to the early 80s and through the center of the 80s. And Commodore 64 is one of them, and that was my first computer, so emulating one of those on a prop is a very, very, very cool thing.
Right. Now the video of the Commodore 64 might be a little bit difficult on a propeller, but fortunately I also added an extension bus that will allow you to add an original VIC chip, or you can add an extra propeller chip that will do all the work of emulating the propeller video. Of course, you already know that the SID sound chip of the Commodore 64 is already available as propeller software, and I imagine in the future this could potentially also emulate all kinds of other hardware like floppy drives and tape drives and things like that.
Now, I recognize the color on this board. This looks like a lane board.
It certainly is.
Yes.
And I got it from one of his medium runs, where you can order at least 10 or 20 boards at a time. In this case, I ordered 20, and something went wrong with one of the boards, but he gave me a refund for that one. So
That's nice of him.
I had.
Lane's a nice guy.
Yep,
Yeah.
I had 19 boards, and I'm selling the kits here, and they will also be sold on Gadget Gangster.
Cool. Excellent.
Well, thank you for explaining us what this is, Jack, and showing it to us. And you're going to be selling these soon, or when you're done?
I'm selling them now.
Okay.
You can buy one now.
Excellent. So we'll throw a link to Jack's stuff on the description of this if it's out in time. And if not, we'll of course be tweeting about it because this is one of our favorite projects that are currently new.
Thank you very much. I'm very honored.
It's a 2.3-inch color LCD, and you can display photos with it. You can do user interfaces with it, all kinds of different things, and it connects straight to the Quick Start, or you can add an IDE cable, just a 40-pin IDE cable, and install it on your project enclosure remotely.
Okay, so this is a touch LCD screen that plugs right into the Quick Start through that adapter board, or just by itself too?
Through the adapter board, because it's a different pin out. You got to have the breakout board comes with it. That's part of the kit.
Okay.
And then you build the breakout board. It takes about 5 minutes, and then you drop the touchscreen module on top. Also adds SD card, so you can use that in all your Quick Start projects too.
All right, that's very, very convenient to have that. So, with that, what's the resolution on that LCD?
320 by 240, so pretty good resolution, and it's 24-bit color. So you can display photos and graphics. In addition, too, you can grab for your existing video and graphics projects. You just swap out the TV video object and you put in the LCD video object, and you got
nice
a drag and drop change.
That'll fill in the hole that was sort of left by that OLED module. That,
yeah,
that
it's a little bit. It's a little bit bigger, but yeah, same idea. You can use that for small UIs and stuff like that. So it's handy. Cool. I use it all the time in my projects, and it's a little expensive. It's $40, so you're not going to use it just for a little baby project. But if you have something where you want to build a UI, it's a pretty good deal.
And where can people find it?
It's at GadgetGangster.com. And the project page is GadgetGangster.com/205. There you go. Okay, so a couple other new modules that we got is the Quick Proto. It's just a prototyper for your Quick Start, and it adds the video, audio, and power connections. So it's handy to build your circuit and drop it right on, and you can have power in addition as well. The other one that Jeff Ledger actually designed this one. This is the Quick Player. It's got a Wii connector and then video and audio. It's really designed to make video games easier to build for the propeller, and it has a little header slot for micro SD. That's Balderdash, which is a classic. I think Baggers did that one. It's a great game. And then the Quick Servo Sensor. A lot of servos have this 3-pin servo connector, and this allows you to connect servos or sensors that use that standard 3-pin out header on your Quick Start board. So you just build it, you have a prototyping area, and drop it on to your Quick Start board.
And again, these are GadgetGangster.com.
Yep, they all have their own project pages right on the home page there, and you can take a look.
And
of course,
so
everything's
examples of things that have been done with them, and lots of code available.
Everything's open source. All the code, all the layouts, the schematics. It's all under the MIT license. You can take a look, download it, build your own, upgrade it, and build all kinds of cool projects with it.
All right. Well, thanks for showing us this stuff, Nick.
No problem, guys. Thanks for checking everything out.
So did you develop this?
For the robot, the servos are off the shelf, so we customize the body and lead in the hand.
Wow.
We design the controller from the ground up. So the controller is a really media controller. So it plays the media file, it just plays the eye expression, the motions, and the voice and sound.
How did you come up with the idea?
Because my wife, she likes to write stories for children.
Oh, okay.
Yeah, so we combine the robotics and the story writing into one.
Oh, that's brilliant. That's great. So you write the stories, and then you make the robots to come with it. That's great.
Experience as you never sleep on our flagship.
Now, was this done first as a hobby, and then?
We actually have this website, estory.ing, in the year 2000. We registered in 2000.
Okay.
So the initial idea was to share children's stories on the website.
Sure.
Yeah, but it didn't really work out for about 2 years, so we just stopped for a while.
Okay.
So in 2008, we restart again.
Yeah.
But this time on, we added
the robots.
Yeah.
How's that been going?
So far, quite okay.
Not too bad, yeah.
Last year, we presented this in this international robot exhibition in Japan.
Sure, yeah.
So we're still talking to some company to see how much interest they have to carry the product.
Well, these are great. I mean, these are as good as, you know, some of the Sony, like the Curio. Yeah, I mean, it's almost the quality's as good as that. So I'm impressed. I'm very impressed.
So this robot has 16 servos,
okay.
8-degree motion, and the eye expression will synchronize with the motion and the sound of the dog. Everything runs from the micro SD card.
Okay. And so is it on a prop or a stamp or?
I'm sorry?
Is it
propeller?
Propeller? Okay.
Yeah.
Okay.
So the current prototype runs on one propeller.
Yeah.
But the commercial version will be in 2 propellers.
Okay.
So why is it 2 propellers? Is because it allows the storytellers to write their own stories.
Sure.
And then to digitize it using our own software.
Sure.
Then you can put it out to the controller to download for MTY user who owns the robot to download for the robot. And then we also allow developers to write new applications for it to do new things, right?
Yeah,
so they can upload it to our website, and then they can download to the end user, so they can really get some money out of it.
Gotcha. Great.
The developer actually uses one full prompt.
Okay.
Write any application.
Okay.
So that we will supply them with all the libraries necessary.
Fantastic. Great.
All right, so we've got the
DVI graphics shield.
The new. This is new, right?
Yes.
Yeah. DVI graphics shield, and the quality on this thing is, for you guys who have done graphics with the propeller, you can get some high resolution modes, but when you do, you don't get very much color depth. And on this one, the color depth is actually pretty good, considering. What is the depth on this?
It's 24-bit true color.
24-bit true color, and that is pretty handy for some things. It looks like it's pretty snappy too. How did you pull that off?
Well, basically, I'm just pulling data right off using FSRW, SD card driver, which is very fast. Pulling bits right off the SD card and sending it 48-bit bus to the SSD. I just graphics controller.
Okay, so you're using an outboard graphics controller to do the heavy lifting here?
Yeah, there's 2 chips. The big chip here is the Solomon SSD 1963 graphics controller, VGA output. Usually it's meant to drive these, touchscreens. I decided to attempt to try it to a DVI output chip.
And because it's DVI, that'll make it very translatable to HDMI and all of the modern monitors that are out there coming out now, including my new capture card, which is a Thunderbolt HDMI capture card for the Mac. So Roy Elfman donated one of these new boards to the show, and we're going to be able to use this to do video capture of propeller projects in high quality video. And that is going to be a very nice thing to be able to do.
That sounds interesting. I hope that works.
We hope so too.
It should work pretty well, as long as the speed is right on the DVI. As long as that's right, it should be fine.
There's a couple other tricks it can do. Here's a board that plugs into the middle. And if you want, a lot of people want regular analog VGA. And so you plug this in, and you can get, we can actually get regular VGA plus HDMI at the same time almost.
So it'll do simultaneous. What's the chip on the center of that board doing the translating?
This is Analog Devices, I want to say 7125. Just a 24-bit DAC. And so that three-channel DAC. So that creates the RGB analog from the 24 bits pixel plot. And there's one other trick it can do. Somewhere around here I have.
Yeah, this board.
I don't see it. I have a board that will connect to these touchscreens. I
standardized.
I have a board that has. It's this size, but it has these two connectors on it to plug into. So you can, if you want to, you can use this board to drive touchscreens.
Okay, and are these up for sale yet?
These adapters, I just have the prototypes right now. They're coming soon.
Okay, and are you going to be supplying those yourself, or are you working with somebody else?
I do everything myself.
Okay, so where can people find this stuff?
It's all at raiselogic.com.
Raiselogic.com. There's the URL for you guys.
This is new. This is Parallax's quick start board, and I adapted one of my designs so that it not only works with my system, but it's also an add-on to the quick start board. For educational purposes. It has push buttons, dip switches, and blinky lights, because that's what you tend to use most while learning electronics.
So in just a little bitty board there, you've got most of the functionality that most people would use off the Propeller Professional Development board, but in a much smaller package.
Yeah, in this case you'd pick up a $25 Parallax Quick Start, which I can't compete with because it would cost me more. But and you add my $30 school board kit, and all of a sudden for $55 you've got 89% of the functionality of the Propeller Development Board.
Which is a $280 or so board. Very expensive.
Yeah,
no, it's a great board, and no, it's much cheaper than that. It's I think about $179.
I didn't have to pay for mine.
Oh, okay. So neither did I actually. And it has a lot more features that my board doesn't. So I actually highly recommend it for more advanced users. But somebody who's looking
Not everybody needs a real-time clock.
Exactly. Somebody who's looking at quick starts, because there's a great way of getting started, is not often going to want to get a high-end board, nor would they be able to necessarily appreciate it.
Yeah.
I mean, I have the same problem here. One of the first products I designed with the Propeller was a dual processor little computer, because I wanted something to be more powerful than the old Amiga I used to program with a lot.
Sure.
And I designed what I call Morpheus, and I designed the memory controller for it, and I added static memory. And here you see Morpheus generating XGA quality bitmap graphics. Right now I think it's running 1024 by 768, 4 colors per pixel from a palette of 206 colors.
Not too bad, not too bad.
I also have a gaming driver for it, which is 320 by 240, 256 colors per pixel, split screen, pixel accurate, vertical and horizontal scrolling, and sprites.
Nice.
Very good for retro style.
I don't know what else to tell you much. Well, I'll get to the system. And this is the one I designed for schools and the people to learn. Here's an earlier prototype. This is a retro gaming computer. Power jack, power button, serial port / programming port, stereo audio, video, S-video, VGA on this side. The board had to be big because of all the connectors. And on this side you have two Sega Atari compatible joystick ports.
And those are still easy to get, right?
Very easy to get. On eBay you can find those controllers cheap. You have RS-485 based networking, micro SD, infrared remote control sensor, infrared LED.
And I assume you're using some sort of a helper chip for those Ethernet ports?
It's not Ethernet. I'm using Ethernet jacks, but it's RS-485, and I use a Cypex RS-485.
Bit banging it out?
Yes, but on a Propeller, you can get reliable 10 megabit bit banging on it.
Yeah, it's fast enough to do it.
Yeah. Also PS2 keyboard and mouse. And memory expansion using SPI RAM or flash or EEPROM, real-time clock, and SPI-based I/O expansion chip to handle the joystick ports.
So that's a pretty full-featured educational board right there.
Yes, and I have this tendency to want to kill multiple birds with one stone. So if you take a look on the bottom, you'll see that it has holes for the temping connectors. So if you don't want to use it as a retro gaming machine, you can populate it with 2 temping headers and use a lot of my modules instead, which I'll get to in a moment. So you can actually use this board as a retro gaming board, propeller software development, because you can run the Sphinx compiler right on it if you had a TV or VGA monitor and a PS2 keyboard. And you can actually also use it as a VT100 terminal replacement or a small industrial digital controller. And the way you do that...
You've got a lot of motor driver stuff down here?
Actually, I don't have motor driver modules with me. I do have a motor driver integrated with my RoboProp controller. This is a dual H-bridge L298. And that's the Robbie the robot, named after my nephew, who I ran a 2-part article in Servo on in the September and October.
And that was a cover story, right?
Yes. Here's the cover of the robot before being upgraded. The part 1 article starts on page 48, and the October issue, I didn't get the cover.
Does Servo have an online version where people can see the article?
Yes, if you subscribe to Servo Digital, you can get all the back issues, and the print issues are also available. I may be able to get some PDFs of it for my website later. I have to talk to them.
Sometimes they'll be nice like that.
Oh, they're actually very good people to work with. And like, basically my concept was to design a Lego TM block style approach.
Very modular.
Very modular. I call it the Micronauts modular system. And you have assorted motherboards, like my development board, a PLC board, Morpheus, and there's all sorts of full-size boards or prototyping boards that plug into it. And there's also a large range of modules, going from a small prototyping board, parallel I/O expansion board. This is an industrial optically isolated input board with 8 channels, industrial solid-state relay output board with 8 channels. This is 12-bit 8-channel analog A to D add-on, and what's unique about this one is I use multi-turn precision pots, so you can have a unique voltage divider on each channel. So you could have one channel read like between 0 to 400 DC, while you've got the other channel calibrated for 0 to 1 volt.
That's handy.
And you can also adjust the reference voltage for the channel.
All right, so where can people find all this stuff?
Well, my main website is unfortunately outdated, but I'll be updating it real soon now. It's at www.micronauts.com. Here, you can close up on that. And my email address is micronauts@gmail.com. I have a YouTube channel at youtube.com/micronauts.
And there's demos of this stuff there?
Right now there's only 2 videos up, but there's going to be a lot more soon, because I'm entering Robothon in Seattle in June. And I'll be entering a large number of robots in various competitions, and I'll be posting videos of the events and other demonstration videos online.
Sure, awesome. It's
well,
a lot of work.
It is, thank you.
Thanks for talking to us.
Yeah. You're very welcome. Thank you for talking.
We post videos all the time, so don't forget to subscribe. And follow us on Twitter at TYMKRS.